Okay, let's try another example. So this is another second order, right, differential equation. It's a homogeneous equation again because the right hand side is 0. Uh, so let's use the characteristic equation. So characteristic equation, it's also called the auxiliary equation in some books, but this book uses the characteristic equation. So if you see auxiliary equation, it's the same thing. It's the quadratic. It's a quadratic equation basically, quadratic polynomial. Okay, so the characteristic equation is going to be r squared plus 7r, right? R is the first derivative, minus 18 equals 0. So again, right, y double prime, that's this guy. Y prime, right, that represents this guy, right? It's really r to the first power. And again, no derivative, so no derivative here. And again, this is, again, just goes back to factoring, your factoring techniques from algebra. So let's see, this is 1, the coefficient, the leading coefficient's 1. There's no GCF, so we can definitely unfoil, right, or factor. R times R is R squared. And this looks like 9, 2, and let's see, probably plus and minus. Right, and again, we know because 9 times, right, we're looking for two numbers that multiply to negative 18 and add to 7. So 9 times negative 2 is definitely negative 18, and 9 minus 2 is 7. So here are our two factors, and we set each factor equal to 0. And these are pretty easy, all right, because we definitely know r is negative 9, so that's our first root. And our second root is 2. Again, obviously distinct roots, just like our last example. So using our same theorem, I think was 5, our general differential equation is C1 e to the r1x. So my r1 is negative 9x plus, right, this is a linear combination of C2, some coefficient, e to the r2x, and my r2 is 2, so I have 2x. And again, I think I want to say, I called that green last time, right? It's that guy. And, oh, I don't know, I think it was purple I used for 2. So again, this is the general solution. So let's try another problem. How about, let's see, what did I call that? Example 2. So how about example 3? And let's try y double prime plus 10y prime equals 0. So that's our second order linear differential equation. Again, let's use our
Here's another 2y double prime plus 3 for m is going to be negative a half. Y prime plus 2y is 0. C 4 times 1 times 2. That would give us 8 all over 2.
Okay, so let's try y double prime minus 4y prime plus 2y equals 0. Okay, again, characteristic equation. So characteristic equation is going to be r squared minus 4r plus 2 equals 0. Again, no derivative, right? So no root. And again, just a polynomial equation. And here, if you try to look for a GCF, right, there isn't one, right, because the coefficient's 1. If we try to factor, which you always want to do first, right, r times r is r squared. So here we're looking for two numbers that multiply, that give me 2, and the same numbers have to add up to -4. Well, the only two numbers that multiply to 2 are 2 and 1. So I know this has to be 2 and 1, but 2 plus 1 is never going to give me -4. If I make them both negative, that'll be -3. And again, if the signs are opposite, it's never going to give me -4. So this polynomial is actually not factorable, right, over the real numbers. And, well, actually I have to be careful. I don't want to say over the real numbers. It's not factorable over the integers, or maybe rational numbers. But just because it's not factorable doesn't mean that there isn't a root. It just doesn't, it's not a, it probably has an irrational, an irrational number. So let's, well, the question is, if you can't factor a polynomial, what do you usually do? Well, you try to use a quadratic formula. You can complete the square, use any other techniques you might have learned. So we're going to use the quadratic formula. So here, in the quadratic formula, a is 1, b is -4, and c is 2. So it's not x, it's r. So r equals, so -b, so there's -b plus or minus, well, again, I'm sure you know the quadratic formula, but it doesn't hurt to write it in. Oops, again, since this is review. Okay, so in general, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, right? Something you probably would write on your cheat sheet. But this is r in our case. So r equals -b. Okay, so what's our b? Our b is right. Here's our a, b, and c. So negative times -4, that's a 4, plus or minus the square root of -4 parentheses square. These parentheses are extremely important. Minus 4 times ac, okay, all over 2a. So it's just 2 times 2, and this is, again, just doing some arithmetic. Negative is positive. 4 plus or minus, we know this guy is 16. And we have minus 4 times 1 times 2, that's just 8 all over. And let's see, I think my a is 1. Yes, so this should not be, so let me maybe put it in color. This is not a 2, right? That's a 1. So 2 times 1 is 2. Okay, so again, this is just some arithmetic. So 4 plus or minus 8 all over 2. It would be nice if this was the square root of 4, or the square root of 25, which is 5, or the square root of 36, which is 6, the square root of 100, which is 10. It isn't, but we can maybe take out a perfect square within that number. So we can say the square root of 8 is the square root of 2 times 4. And we have, well, we can break this up. The square root of 2 times the square root of 4. And if you want, I can write all this over 2. It's the same thing as breaking it up. This is great because the square root of 4 is 2. And, well, we know 4 divided by 2 is 2. This guy, right, I'm going to bring it over here. And that's really a 2. So we end up getting this value. And I mean, remember, we're solving for the roots. So R1 is 2 plus radical 2. R2 is 2 minus radical 2. Right? Radical 2 is about, and actually, it's kind of fun that we're talking about it because the square root of 2 is about 1.4. The way I remember it is Valentine's Day, since it's coming up on Saturday. Valentine's Day, right? February 14th. That's how I remember it. Anyways, I just saw the square root of 2 in there. Okay, so we have a final solution. Y of x equals C1 e to the r. Okay, so 2 plus the square root of 2. That's your r, x, and I think I need to write it in green. Right, that's my r1 plus C2 e raised to the 2 minus radical 2, right? That's my r2 times x. And that is our final solution. So you might factor a GCF, it might be factorable, it might not be factorable in this case, so you can use a quadratic formula, or you can complete the square, or use a square root property. Again, feel free to use any of the factoring techniques that you have learned in the past. Okay, so I'll stop here and I'll do a couple more in the next video.